Hello everybody. In what will be the first of, I guess, a few videos to come, I often get a lot of items for repair. So this being the first video, what I actually have here is a 10-inch digital photo frame, and I actually have two of these, with the problem being that they have stopped working as they've been running 24/7, I believe. They seem to be in a commercial situation. So we're going to get stuck into it, and here's the first one. We'll rip it open and see what we can see. First up though, I'll be checking the power supply. Now, just a standard wall wart plug in the wall adapter, so I'll check those first and make sure that there's something coming out of them. Right, so this is a 12 volt power supply. Simple test shows we are getting pretty much 12 volts out. Right, I've switched it on, and when I turn it on, what I can hear, and I'm not sure if the microphone will pick this up, is a rapid pulsing noise coming out of the speakers. Now, it kind of got a bit louder for a bit there, but what that suggests to me is that something in the power supply section internally is likely having a hard job starting up and is constantly shutting down due to some fault, and starting up and shutting down and doing that in rapid succession, which is causing some weird noise out the speaker as I guess the amplifier power section is jumping off and on. So we'll whip the back off and see if there's anything obvious. Right, well, they've gone to some lengths to make this look like a decent sort of old school photo frame. Just undid the screws and the whole front section with a large piece of glass has separated away. So it looks like a couple more screws and the guts of it should fall out. Right, so it appears that the cardboard fascia surround there has had to be unstuck, and they've got down there what looks like, I thought it might have been an LED, but it appears to be an infrared receiver glued and stuck onto the back side there. So we'll pop that off, and then there's just screws in each corner, and we're almost there. Alright, let's have a look under the lid. Okay, a couple of speakers. Yeah, I guess that's fairly typical construction for a photo frame. We've got the main image processing board, and that goes out to an LCD, which is quite a chunky LCD, really. It's huge. It must have one hell of a backlight arrangement on it. On the other side, we've just got some buttons, control buttons, and the on-off switch and power in there. So I think what I might do first is disconnect the display and the fluoro backlight and turn on and just see if it gets rid of that noise, if maybe the screen itself's loading something down too much. Right, having completely removed the screen there, if I flick that on, we're still getting that noise. There's something over here is not too happy. Let's do the old finger test and see if something's getting hot. Right, so what I'll do now is just check the input voltage and make sure that when it's on, the plug pack there is actually supplying the 12 volts still. And we've got 12 at the moment, so I will switch it on. And we'll pop over to our meter, and oh, what do you know? It's dropped to 5. Something's really loading it up, or maybe our plug pack just can't hack it anymore. Let's do some more testing on the plug pack. Okay, so what I've got here, and what I probably should have done to start with, is I've got a little device here that I just jimmied together when I was doing a lot of power over Ethernet related stuff. It allows me to just plug in a 12-volt supply and it would feed power out to the device. In this case it was wireless, a wireless device, and it allows me to switch. There's a switch there and a resistor, a 12 ohm resistor. Allowed me to test power supplies as well as feed the unit I was working on, and basically put a 12 ohm load across what we mostly use 12 volts, so that's 1 amp, and these power supplies are rated at generally 1 amp or more. The ones for the photo frame are rated at 3 amp, so should be able to handle 12 ohm resistor. So 1 amp. It also allows me to hook the scope probe to it. Bit of a closer look. I don't know why my camera is not focusing. I told it to continuous focus. Maybe if I try... No. Okay. Now, hook that up to the scope, and with the load not connected, look at that. That line there is jumping all over the place. That is not too good to start with. I mean, in saying that, okay, it's probably because it's offload, and it's just yeah, it's jumping up and down. It's jumping at about, what are we, 5 volts per division there. It's about 12 volts I can measure on the meter, within a volt or two. So when I switch the load in, I can see the light on the camera through the reflection. Okay, so when I switch the load in, we'll see what this does. Now, just try and get a better focus. That's better. Right. Whoa, look at that. That is not too happy at all. 3 amp capable supply can't even do an amp. It's dropped right down to rock bottom. And if I flick that to, what, 2 volts per division, it looks like it's barely able to reach 3 volts. That's shocking. Well, I could crack open the power supply. It is a fully sealed unit, so yeah, we'll crack that open and have a look, just because we can. But at this stage, you would probably just throw it in the bin and go buy a new power supply. But let's crack it open. And I'll just switch that load off and see if it comes back alright. Oh, off the chart. There it is. Okay, we'll crack it open. Okay, so one method that I use first is good old bench vise, and what I do is clamp it just beside the seam so the jaws aren't covering the seam itself, and then wind it in. I'm just holding a little handheld light there so you can get a good view, and let's see, I wonder what this is like. That triggers the focus better. So yeah, so just beside the seam, and wind it in, and you'll generally hear a crack, and come up here and you'll see what's actually happened over this side. As I wind that in, it's started to spread, and it has actually let go along this top seam here, and so I'll get in with a screwdriver and wedge it open. Alright, now just turned on a bit of extra light there, and here we go. Top just, the end of it flips off. Bottom side of the PCB there. Now, of course, you want to be very careful in stuff like this. There are high voltages. Any switch mode power supply running off 230 volts as we do is yeah, potential to have about 400 volts in there, so not nice to touch. Light is actually quite glary, isn't it? And this focus isn't focusing. Why isn't it focusing? It is on continuous focus, so amateur cameraman, what are you going to do? Right, so what we need to do is get this out of here and have a look over the top side and see what is underneath it. I'm picking it's going to be in any situation where a switch mode power supply, there we go, is failing under load is generally the output capacitors. It's what I've found. Typical telltale signs that I'm not actually seeing in this one. There's the capacitors there. The top will be sticking up instead of being flat, and possibly even split right open in really bad situations. I mean, of course, there's a chance that the primary side of it is not up to speed and able to switch properly. But as I say, generally it's those output capacitors. So what we can do is pull those out of there and test them and see if they're up to spec. Now, when I mentioned the high voltage, of course, this one here, this capacitor here, it's got the high voltage 400 volts rating on the side of it. That's the one you want to be very careful of. And there's also actually another one over there, interestingly enough. They've got two of them in this one. So that one there. And when you look over the other side, you can see where their pins are, and generally you want to stick your voltmeter on there and make sure that they're well below dangerous levels, you know, below 30 or 20 even. I mean, you'd have to have fairly low resistance skin to feel 30 volts, but you certainly don't want to be touching anything higher than that. Right, let's whip out those capacitors. And for all those curious, this is my solder station. It's a hot air rework station. It says it could go up to 400 degrees C, but that remains to be tested and proven. Although it does get hot enough to do most things. Certainly the end of the iron isn't the biggest. There's a few tips, of course. I purchased this one from JCar Electronics, and comes under a variety of different badges, but is generally the same beast, out of the same factory, I've come to find. And this is my third machine. I've had two of them fail within 12 months each since getting them. Autofocus having fun there. But this unit, it's a redesigned unit. It has a main switch on the back rather than a main switch on the front, and that's I don't know if they've changed the guts of it, but seems to be a lot more reliable than the other one. The other one I had would do well. The first one failed. You couldn't really see. Well, actually, you couldn't see anything on the screen. It went totally blank, other than the backlight. And the second one, half the digits stopped lighting up, and wasn't really. You couldn't really control the temperature of it. So no, this one, if you see this model, I'd say get the one with the power switch on the back, and should be more reliable. Alrighty, so we have a couple of capacitors nicely glued together, and 1000 microfarad, which seems to also be a common value for use in 12 volt output sections, in these plug packs at least. So we'll check those values to see if they're any good. Now, I've only got a basic capacitance tester. I don't have an ESR meter, and I would love to have an ESR meter, but we'll see what they come up as anyway. Alright, so they measure at 988 and 960 microfarad. which is starting to get a bit low given that there should be 1,000, so I'd be suspecting something up, and their ESR is probably not that good. Now I don't have 16 volt, well, not sure if that one's a low ESR one, but I don't have them in that size. I've only got them in a bit bigger, and it's probably a bit large to fit under the cap there, so I might just stick them in and just for a quick test and see if that works, just to prove a point, and if it does, I'll look at getting some proper ones, and we'll go from there. And there's our new caps in place, and it looks like they'll actually fit, so it'd be nice to know if that was a low ESR one, that black one. I know for sure the green one is, it says so on the sticker on the side of it too, but yeah, let's plug it in and see how it performs. Right, we've got it rigged up to the 1 amp load, so to speak, and fired up on the scope there. Now it's still twitching away off load, but we'll see what it does when I switch it on again. Oh, she's not happy. I guess there's more to it than the output caps. Better crack it back open and take a closer look. Okay, so just had another idea and checked the main filter caps. Now they are, well, that one and that one, they've got two of them in this particular model. They normally just have one. Just to see if they're all right, because the other theory I've got here is that maybe it's not developing full voltage on here, so therefore it's unable to switch enough current out to the secondary, to the output, and they seem to be okay. So the next thing I'll do is check the bridge rectifier. Now that converts the 230 volts AC, that's just hiding under here, to DC, which is about 400 volts DC on those two capacitors. And so I'll just check the bridge rectifier and go from there. And I've disconnected some of the leads on the bridge rectifier just to remove it from circuit, enough that the test will be conclusive, and that's actually okay, which isn't too surprising, because yeah, if it had, they usually fail short circuit, and that would have taken out the fuse if that was the case. Right, I have pulled out another capacitor, and that one, here's our main filter cap, and that's our 400 volts. That goes through a two 1 mega ohm resistors, so 2 mega ohm resistors. It's a 2 mega ohm resistor, 2 meg ohms resistance total. It's getting a bit late tonight, and it goes through those two and into this other capacitor. Now this capacitor is a 10 microfarad 50 volt. And that's across this little IC, which appears to control the switching of the primary. So I suppose if that's a bit unhappy and it's not getting its full voltage that it requires to run, then yeah, that could be an issue. And it does. It's 10 microfarad. It is measuring at about 8.4, and it was actually dropping slowly, which I don't think is a good sign either. So I'll go ahead and replace that cap, and we'll see what happens after that. Okay, so that little capacitor replaced, that sits in the supply voltage rail to the control IC. I must say the line is looking a lot more stable with no load on it. It's not jumping up and down all over the place, and it's looking pretty bang on 12 volts. Now we'll flick the load on and see what happens. Alrighty, load's on, and it hasn't flinched. Still looking at 12 volts and maybe slightly above 12, but she's definitely sucking 1 amp through that resistor. It's getting nice and toasty. So I'll call that fixed. Now I know I don't have I'm not sure if the secondary output capacitors were ESR, and it wouldn't be worth risking a non-ESR one in there, because I've seen them and they really explode. So they can't take it after much more than probably half an hour or a couple of hours. So yeah, I might throw the old capacitors back in and see how it goes. They're obviously okay. They were a little low, but that might be might be all right for now. I mean, I'm certainly not going to be flogging them off for huge amounts of money and whatnot. So don't need to make make them as reliable as brand new. I can always, if need be, I'll replace those a bit later on. But yeah, we'll plug it into the panel and see if we get a picture out of it. Okay, I've got the screen back together, so we'll switch her on. Oh, there we go. Yes, this is a Dick Smith branded device. Certainly takes a while to boot. Yeah. No? Nothing? Ah, Murphy's Law. Anything can go wrong, it will go wrong. Hang on, let's push some buttons on the side. So on the side here we've got volume, it looks like, and maybe a play button. What does that do? No. An up down button? No. I heard the speaker make a noise. There's another button on the side there. Oh, I can kind of make out something in the background. Still looks like the Dick Smith logo. No. Oh, there's a clock. I wonder where my backlight's gone. That's not flash. Maybe it doesn't like the card format or something. Alright, let's have a closer look. Right, so I've had a poke around under this foil on the back of the screen, and it appears it's got the cold cathode fluoro driver circuit under there, and this connector back on the board here, as it comes down here, it's quite interesting what they've done. They've separated. They've got two wires for positive and negative, and they've put them far apart on the connector, which is kind of what they do for the high voltage stuff. They'd separate them if this was going up to the tube itself. But this is only carrying 12 volts. So I just checked that, and it's 11.8 when it's on. Not overly low. I would think that's acceptable. So it's and when the screen goes dark, there's still 12 volts on there. So must be something going on under the foil. Let's lift it off and have a look. Right, so what I've done now, I've removed each of the fluoro tubes in turn to see if the board would stay running. I'm thinking it's one of the fluoro tubes now. If I unplug that one, the overall brightness loss isn't really a huge amount. And if I unplug the other one, this one has a little bit of a pinkish tinge to it. So I'm thinking the fluoro tube itself is failing, and it's possible this circuit is recognizing that, and that there's not enough, maybe there's a tube current sensing going on, and it's not firing the right amount of current, so it's shutting down. Looks like they've glued the thing to the back of the screen, so it'll be a pig to take apart. I was just thinking I could use the other unit as a test board, because that works, just to prove it's the fluoro tubes. But I think at this stage I'll pull the tubes out and see if they're something I can get a hold of easily. Otherwise, it's working in the background. If you shine the light on the screen at the right angle, you can see the pictures changing and the menu systems work. And other than that, she works. The only other option I have is to get real cheap with it, because the brightness could possibly be a little down. I could bypass the protection on this and stop it from shutting down. Just permanently hardwire it on. I think I've seen one in a different machine. There's a pin that gets pulled either high or low to turn the thing off and on, and you can see it drop when it shuts off, and tying that on all the time kept it running. So I might have a look at this one and see if it's something I could do, and see what happens. Okay, so a bit of an unexpected twist in the story. Now, as you can see, there's 3 wires to the fluoro tubes. The white one is a feedback current sensing, I suppose, feedback for the tube. And what I found is that on this tube, if you're monitoring the drive IC, it drops to about 1.6 volts, whereas the left-hand side is dropping to or below 1.3. It just starts at 3. They both start at 3 and slowly ramp down, I guess, as it gets control of itself. But the left-hand side is dropping below 1.3, and at that point the system shuts off. And inadvertently, I had this unplugged while I was just manually separately powering the inverter board separate to the main board, and I had that unplugged at one point, and the whole thing kept running. And I thought, hello, and a bit more probing, and the left hand side sits down to about 1.3 volts, whereas the other one's about 1.5, 1.6, and the feedback, so it's on the borderline of cutting out. And when I plug this connector back in, it'll shut off. And I'm thinking, okay, and so I monitor the voltage again, and if I touch it while that's unplugged, if I touch the metal, you can hear the oscillator pitch changing, and the voltage drops. So there seems to be some high voltage breakdown in this tube, and it's very slow or small leakage of high voltage through to the back panel. That having this plugged in, the ground side of it must have just added enough load to drop the feedback voltage enough to shut it off. So whether it's in the wiring or at one end of the tube, maybe there's some high voltage silicon or something that's broken down and it's arcing the tube. I can't feel it if I touch it. It doesn't hurt. There's no tingling sensation, but you can certainly see the effect. It might need a whole new tube, or I might be able to pull it apart and squirt some silicone in there or something and see if that seals it up, and it might keep going for a while. Yeah, she's a fairly well built display. So, but that's where I'm at. I might leave it at that. I might rip the screen open and yeah, why not? Let's rip the screen open. Let's have a nosy and see if we can see any marks, any RF burn marks somewhere that might be an obvious spot of leakage. Worst case, I could just cover up both ends of the tube with something and see how it goes there. Alright, got the screen apart. Probably went to a bit more trouble than I needed to, having removed the LCD itself from the front. That actually could have stayed in place while the back shielding came off. But this is the tube. It just slides in along top and bottom edge. Now it's a double tube. There's actually two tubes in there. I'm not sure if you can get a... No, it won't focus. One of them is you can see quite a noticeable black spot at one end there, and at the other end there on the top tube. I believe that's indicative of a nearly end-of-life tube. I don't know if it would be arcing through the glass, so to speak. I suppose they're very thin glass, and I guess if it's not able to strike an arc through the length of the tube, it could find the nearest path to ground out through the side of the tube. But instead of trying to pull these two tubes out, because I mean, I'm sure you can. But this black strip across the back of it is holding the white return line, feedback line. So they won't slide out without peeling that off, and I don't know if I want to peel all that off and have to relay another one. So I might just completely isolate this bar from the back shielding panel. It's only into a plastic frame here, so I only need to run tape down one side of it, and that'll completely shield it from the back. And it may isolate it enough to just keep working. Of course, I don't know for how long, but that's not really an issue at the moment. I don't know if these double tube sections are easily available. Plenty of single tube online locally anyway. I don't know if I'd want to order them from overseas, but I'll have a nosy around, and if I can find some, we'll replace them. But we'll just run some tape over the top of that and isolate it and see what happens. And there's the tape running across the metal outer of that tube. And there's the exposed one still. Alright, we've got it back together, so let's power it up and see what happens. Okay, it's running. We've got it connected up to the main board, and it's still running. How about that? It's still running. Marvelous. Let's stick it back together and see if we get what the picture's like. Okay, moment of truth. On. We have the logo, splash screen, a picture. Nah. Wah wah. Alright. Looks like I'm going to need a couple of fluoro tubes to make this one work, but that's a shame. Let's power up the second one I've got and see what that does. Alright, here's the second screen. It has silicon around the edges where it was permanently mounted in some place, but yeah, it's quite a dark photo, that. One moment. Right, horribly reflective, but there we are. That's quite a good image as well. Yeah, not too bad at all. Has some nice fade-in effects and things. Has calendar. It has some internal memory. It has a USB or SD card slot. But yeah, thanks for watching.